Hey, Braden.
I'm Miss Sparks.
How are you?
I'm alright.
Do you want to work on the riddle worksheet together or the book work?
I think the book works the harder stuff. I think I can do the sheet, but if we could do the book work, please.
Okay. All right. I'm. Oh, sorry. I was trying to upload the riddle just in case.
Okay.
Just in case. And I had it on my computer, but I didn't have it in Google Drive yet. So that's what I was trying to do.
Gotcha.
Did you have a particular place that you wanted me to start or just start from the beginning?
Just from problem 21, I guess.
Okay.
Yeah.
I have to go through so many steps just to share my screen. I think they should simplify it a little bit. And I'm trying to think. Oh, you know what? I need to pull a graph in too, don't I? That would probably help.
I guess so, yeah.
Let me see if I can find blank. Oh. I thought it was really blank and it wasn't.
Are those the problems from the book or no?
Actually, this looks like it was Algebra 1 from last year. Crazy, huh? It
Yeah.
looks like, to be honest with you, yeah, that's what it looks like. So I don't know what happened. Probably whenever I write on this particular blank sheet, like today, I'll write on it, and then what will happen is when I close this file, it'll save whatever you and I worked on.
Oh, okay.
And I wish there was a quicker way to erase too. Like, I don't know why, unfortunately, it takes so long. And I wish they just had a thing where it says wipe it clean or undo all, or I don't know, something. Something I wish it would do. And now I'm pulling up the book. So I have it on my other computer so I can read the problems the same time. So you're not having to read the problems to me for each individual one. Yeah, and a couple people said they couldn't show up for math lab, but they had questions, so I was having to work some of them out already and then stay the whole time.
I'm not gonna be. I gotta go to baseball in like 20 minutes.
Oh, bless your heart. All right. Well, let me do a couple things then. Were you supposed to do all 21 through 41 or was it odd? I can't remember.
You said do odds, but yeah,
Okay.
there's I don't know.
All right. Well, I'm going to definitely do I'm going to walk through a few of them, but I'm definitely want to do 27 before we get off the phone. Okay. Or off the phone, off the Google Hangout. Lord Jesus, help me. Okay. I'm going to switch back and forth between the graph and this blank page because I'm going to do the work, like the vertex and all of that stuff here. And so that so that there is a clear process for you to do these problems every single time.
Yes, ma'am.
What I want to do is remind you that it's y equals ax squared plus bx plus c. That's the format this is in. So in this problem, what is a?
It's going to be 1.
Good job. What is b?
B is 2.
And what is c?
C is 1.
Correct. So now we're going to do negative b, or opposite of b, over 2a equals. And so b in this case is 2. So we'll just plug in our 2 for our b. And then 2 times a would be 2 times 1. So we have
So it
negative
would just be
2
1.
over 2, which equals
And
negative 1.
Yeah.
Okay? So now we'll
Yes,
take that negative 1, because that's going to be the x value of our vertex, and also it's going to be our axis of symmetry. Okay?
Yes, ma'am.
So I can go over here. All right? The axis of symmetry is a sort of like an imaginary line, if you will, that's going to divide my graph in half.
Yeah.
So I'm going to plot that. And now to get the y coordinate of the vertex, I'm going to plug that negative 1 back into the equation. So I'm going to have negative 1 squared plus 2 times negative 1 plus 1. Negative 1 squared is 1. 2 times negative 1 is negative 2 plus 1. So 1 plus a negative 2 is negative 1 plus 1. So that's 0. So my vertex is going to be negative 1, 0.
Okay. And then you just do the points and that kind of stuff. I think I was having more of an issue with getting the points than like actually putting it on the graph, because that's easy.
Okay. You're okay with the graphing part?
Yes, ma'am. That was just the part that I had difficulty on.
Okay. All right. Thank you. Because I want to zone in on, because since you have to leave for baseball, I really want to zone in on where the struggle is. You know what I'm saying?
Yes, ma'am.
So what I would do, Braden, is when I'm doing a like a chart of points, you want to stick that vertex kind of in the middle of that chart. Okay.
Yeah, that's what it
And
said
then
in
you
the
want to
video.
go 1 up from it, which is B0, and I'd go 1 down. Okay.
Yes, ma'am.
Does that make sense?
Yes, ma'am.
And actually, if I go 1 up in this particular case, oops, that should have been negative 2. My apologies. If I go 1 up, whenever there's a 0 in the x coordinate, I know that that's going to be the y-intercept, right?
Okay. Yes, ma'am. Yes, ma'am.
Okay. So the y-intercept in this case is 1, right?
Yes, ma'am. Yes, ma'am.
Okay. Because that's how we figure that one out. But so that's going to be 1. And guess what? Due to the rule of symmetry in a parabola, I'll show you the work, but I can pretty much bet that this negative 2 is going to turn out to be 1, because the symmetry is supposed to be that.
Yeah. Yeah. I get what that is.
You get that? That means, do you want to see me do the work? Just to see it plugged in.
I don't need you to. I think I understand it.
Okay. All right. Because I was going to say, just to see it, sometimes it helps to see it. I've got my points plotted in purple, and then I'm just going to draw that like that. So there you go.
Okay.
There's that one.
We can just go ahead and skip down to 27.
Yeah, because that one has been the one that I've gotten the emails about today. So that's the one I want to work with you. Okay?
Yes, ma'am. Yes, ma'am.
And we're going to apply the same principles. But, because there's a fraction in it, it makes it spooky, scary, and ugly,
Yes, ma'am.
And so once I do this for you today, and I did it for a couple of other people, y'all can do it on the board tomorrow.
Oh, yeah. Okay.
You sound so excited about that.
I'm thrilled, Miss Sparks. Absolutely thrilled.
I thought you would be. Okay. Y equals 2/3 x squared minus 3x plus 6. Did I write it right?
Yes,
Okay,
ma'am.
what's A in this case?
2/3.
Yes, sir. It's a beautiful fraction. What's B?
B is -3.
And C?
6.
Okay, good job. All right, so our formula for the vertex, the x coordinate of the vertex and or the axis of symmetry is the opposite of B over 2A. So the opposite of B in this case is going to be the opposite of a -3 all over 2 times 2/3. So 2, so the top part is going to be a 3, and 2 times 2/3 is 4/3.
Okay.
So we've got a complex fraction here.
Yeah.
And what that means, the big fraction bar is really a division sign, right?
Yes, ma'am.
So what that is saying is it's 3/1 divided by 4/3. And the rule of fractions, KFC, tells us to keep the first, flip this to multiplication, and change the final fraction to its reciprocal. So then we have 9/4 as our x coordinate
Okay.
in our vertex, as well as x equals 9/4. And that graph would look like 2.5, like a 2 1/4 is going to run right through here. It's not real exact, but it's close.
Yeah.
So now what I'm going to do is take that 9/4 and I'm going to plug it back in to the equation. To solve for my y. Now I'm going to simplify before I multiply here. Two, 3 goes into 8 2 times, with 2 left over, so 3 goes into 20, so that's 27. So I've got y equals 27/8 minus. Now, what I do know is that when I'm subtracting fractions, I have to have a common denominator. So I've got to change that 4 into an 8. And 4 goes into 8 2 times, and 2 times 27 is 54. And then I've got to change this final number into a fraction. And this is really 6/1, and 1 goes into 8 times, and 8 times 6 is 48. And then the next thing that I'm going to do is take 27 minus 54, which is -27. And if I take -27 and add 48, I'm going to get a positive y equals 21/8. So my y variable, and also my minimum value is 21 over 8. So that's roughly 2.5. It's a little over 2.5, I think. One was like 2.5 and the other was like 2.625 or something like that.
I can type into my calculator.
So my vertex should be about right there.
21 divided by 8 is 2.625.
Yeah, that's what I was thinking. It's like 2.625. My graph's pretty small. But the next thing that I would do on this particular one, do you care if I erase this work? Have you got it?
Yes, ma'am.
Okay. Okay. The next thing that I would do, I'm going to process this out loud with you while I'm erasing. Looking at the equation and knowing that if we don't have to work with fractions, we'd rather not work with fractions, right?
Yes, ma'am.
What I would do if I was going to find another x value, remember how I said before, try to go one up or one down from your vertex. Like you put the vertex in the middle of your xy table.
Yes, ma'am.
Remember? Like, let me kind of do that over here. We would put the vertex, which basically this is x and this is y. We would put that 9/4, which is roughly 2.5, and the 21/8 here. Well, you know what? A couple things that I can do if I'm thinking about that is, well, I don't really want to go one up from 9/4 because that's going to be like 13/4. So what I want to do is go one whole number up, to work with a whole number if at all possible. But what would be even better is if I could think of a whole number greater than 2.5 that would eliminate that denominator, right? That would cancel it out. So what I would pick then is the number 3, because that's larger than 2.5. Yes.
Yes, ma'am.
And it's going to eliminate. And let me show you how it does that. Because I'm going to look at that denominator and think multiples of 3 are going to eliminate that fraction. So I'm going to stick in 3 here. Does that make sense to you?
Yes, ma'am.
Okay, good. Because sometimes I get to be a little like, I think in terms of math probably, like all the time. So I'm going to simplify before I multiply. And look, what a beautiful thing. I no longer have a fraction. Oops, I left that out. Oh, I don't do that. Oops, my bad. This should have been 3 times 3. I no longer have a fraction because that's going to be a 6. Does that make sense?
Yes, ma'am.
Good. So my point is going to be 3, 3. So if I go back over here, it's going to be right there. And the other thing that I know is that my y-intercept is going to be 6. So 1, 2, 3, 4, 5, 6. So I've got really almost 5 points that I can plot. Does that make sense?
Yes, ma'am.
All right. What other one would you like me to do?
Can you just go back to the chart, the X and Y chart, so I can just look at those points one more time?
Oh, yes, sir. Absolutely. I'm sorry. Yeah. What would I have done on here since that's like 2.5? I don't think it's quite going to be. Let's see. 3, 4. I'm going to double check that one. Should work out, but it's not going to be quite as pretty. When you go up 1, that's up half. Did you get that one?
No, ma'am.
Okay. Are you still working on the chart?
Yeah, I think I'm good. I don't know. I don't really know. This whole thing's kind of confusing with the fractions and junk.
Oh, with the fractions for you?
Yeah. I mean, like you could just do, because 9/4, or we said 21/8 is basically it's 2.625 or whatever.
Yes,
So
sir.
9/4 that's what it is. It's going to be 2.25. So basically going up, and like a whole number from that would basically be like, I don't know, like 1.7 something probably. I don't know.
Right, but
I mean, you
going
could
up.
round it up to 2, I
Uh,
guess, and then you could round 21/8, which is 2.6, whatever. You could just round that down to 2 as well, I guess, because the other point is 3/3. So maybe it would be 2/2.
yeah, let's take a look at it. Let's go over here. So, like, if I'm counting over, because like you said, if I'm counting over 1, it would be roughly 3, be about 8/3. So it's not quite sitting there, right on the line. I'm going over 2. And because of the fact that it's off just a little bit. Does that make sense?
Yes,
You
ma'am.
you you had it. You were thinking about it right. You were thinking that you weren't, but you were.
Okay. All right, Miss Sparks. I actually got to go now because I got to get to baseball practice. But
Okay. Well,
I'll try
we'll
to
do
get
this one again,
those.
and I'll go back over the chart and everything tomorrow in class since we didn't really get to finish. Okay.
Okay, thank you.
Hopefully that will help. And
Yes, ma'am.
I'll also send you a picture of it completely worked out so you'll have it.
Okay, thank you.
Okay, no problem. Talk to you later.
All righty, thank you.
Bye bye. Hey,
Hey, Miss Sparks.
I didn't realize Benjamin and Garrett. I didn't realize you guys were here.
Hey.
How are y'all?
Good.
Good. How long ago did y'all join?
I joined a good while ago.
25
okay.
minutes, maybe.
Oh, okay. All right. So you saw me going over the one. Is that number 27? Were y'all struggling with that one?
Yes.
Yeah.
Okay. Did that help a little bit?
Yes, ma'am.
Okay. And what was I? When you plug in that 2, because like I'm taking 2.5. And subtracting 1, that was the hard part, because when I'm going up a half, I technically shouldn't have put a 2 there to even it out. It should have been more like I'm trying to think. 9. If I'm going from 2.5 to 3, I'm only going up a point, so it should be more like 2.5 would actually be the place where it would actually get to be 2. Does that make sense? I'm making sense, like there, because from here to here is only a half. Does that make sense?
Yes.
So if I went from here to here, that would be the 3, and that's what I was just trying to. And it was because my graph is so small over here, it's kind of hard to see. Not 2.5. Not 2.5, but
2.
Yeah. Yeah. But this doesn't come to be 3. It's actually 8/3, because when I plugged it in, it was 8/3. Unless, did you get something else, Benjamin?
No, I got that.
You got 8/3?
Yes, ma'am.
Okay. Yeah, no, the fractions made it lovely. Was that, Benjamin, was that your only question? Was that one, or do you have some others?
That one and 29 a little bit, but you kind of like with the fractions, I kind of understand now. So
okay, it's just uglier.
Mm-hmm.
It's just not quite as user friendly. I was going to say I was going to pull it up, but that's the other book. But let me take a look at number 29 and let's just do it, because it helps to have practice. You know what I mean?
Mm-hmm.
I have to pull it up on my other computer. Number 29 is is -3/5.
Mm-hmm.
Okay. And I feel like tomorrow in class, and Garrett, I know Miss Wynn did it yesterday a little bit, but Benjamin, I think I'm going to go over this a little bit more in class tomorrow. Is just reviewing exactly being able to identify A, B, and C, because sometimes if you just take a minute to actually write those to the side, it's kind of helpful to keep all of these other things, you know, straight in your head, because there's so many moving parts, I guess is the best way to say it, when you're trying to find the vertex, the axis of symmetry, stick in the y-intercept, and all of that other stuff. It's just easier if you identify those right out of the gate, which if y'all were on there earlier, you probably, number 29 was -3/5 x squared plus 2x plus 2. So A in this case is -3/5. B is 2, and C is 2. So if I have negative B over 2A, I've got the opposite of 2 over 2 times 3/5, -3/5, equals -2 times -6/5, which is the same as -2 divided by -6/5, which then is -2 times 5 over -6. So I'm going to simplify before I multiply. And that's going to give me -1 times 5, which is -5 over -3, which really is 5/3. So my axis of symmetry and my vertex, my x-coordinate for my vertex is 5/3. So now I want to take that 5/3 and plug it back into the original equation to get the y. Bear with me just 1 minute, gentlemen. Sorry. I was trying to find the equation over here, so in a different place, so that I wouldn't have to keep going back up. So I've got -3/5, and then I'm going to have 5/3 squared plus 2 times 5/3 plus 2. Did I write it all right?
Mm-hmm.
Okay, then I have -3/5, and then I'm going to square that, which is 25/9 plus 10/3 plus 2. I can simplify before I multiply. Which that's going to give me a -5. Plus 10/3 plus 2. Have to have a common denominator. So that's going to be -15/3 because -5 would be the equivalent fraction for -5 with 3 as a denominator is -15/3. Y'all understand that?
No,
Yes, ma'am.
I don't get it.
Okay. If I have a -5, I'm going to express that as 1. And if I'm trying to make an equivalent fraction with 3 as the denominator, 1 goes into 3 times, and 3 times -5 is -15. That would make that an equivalent fraction. Does that make sense?
Mm-hmm.
Okay. And now I'm going to do the same thing over here. One goes into 3 times, and 3 times 2 is 6. So I have -15 plus 10 is -5, and -5 plus 6 is 1/3. So my y coordinate of my vertex is 1/3. So my vertex is 5/3, 1/3. Nice vertex, eh?
Mm-hmm.
Oh, wait. Did I do that right?
Yeah.
Okay.
I'm pretty sure. And then
Oh, wait. I didn't. I saw a math error up here. Right here. This should have been over 3, right? Yes, right? Yes. Total math error. I'm so sorry, guys. Do you see what I wouldn't even had to reduce my fraction. Do you see that, Benjamin?
I think so.
Sorry about that. Let me rewrite that so that y'all can see it better. Because even I couldn't see it's bad when you can't read your own writing. -3/5, and then that's 25/9. Nice 25 there. So I missed my 3. I canceled that, but I missed my 3 down here because -3 goes into that. So this would have been -5. I was like, wow. Okay, so I've got -5 plus 10 is 5 plus 6 is 11. So it's 11/3. So that's going to be beautiful to graph. I love graphing fractions. Do y'all want me to graph you like me to graph in addition, or do you like me just doing the number parts? What's your
graph it?
Yeah.
Definitely graph it.
Mm-hmm.
Sorry about my dog. All right, so let's take a look at this. And I'm graphing my axis of symmetry is -5/3, correct? Was it negative or positive?
It was positive.
It was positive? Okay.
Yes.
I couldn't remember. Thank you. So that's roughly 1 2/3. Yay. That's going to be easy to graph. Not really. Especially on this thing. All right. So my axis of symmetry is that. And then my other point is going to be roughly 3.6667. So 1, 2, 3, almost to 4. So my vertex is right about there. So there's my vertex. And now I want to come up with a couple of points. And like I had said earlier, when you have a fraction in your equation, and hopefully you only have one, the best number to pick is going to be one that eliminates that fraction. So you're going to look for eliminating the fraction by getting that common denominator. Does that make sense? So what I'm going to want to do is my point was 5/3, which is roughly 1 2/3. So definitely, if I used a 5, it's definitely up from there. Does that make sense? Or no?
Yes, ma'am.
Okay. How about you, Garrett?
Yeah.
Okay, good. So that'll help us in getting our other point. We don't need that many points. To graph our parabola. So I'm going to stick in a 5. My vertex was 5/3 and 11/3. And so I'm going to stick in a 5. Let me write this so that it looks like a fraction because it makes that simplify before you multiply a little easier. And maybe I'll be able to read my own writing this time. 5 goes into 25 5 times. This time I'm going to get a negative 15. Plus 10 plus 2. So that's going to give me a negative 5 plus 2 gives me a negative 3. So if I go over here and put 1, 2, 3, how in the world? That's not going to work. Oh, yeah, it is. Praise the Lord. 1, 2, 3, 4, 5. 1, 2, 3. So if I'm looking at this point, and I'm going to go down here, I'm going to go over 1, 2. It moves, and this isn't going to be exact, but 1, 2, 1, 2, 3, 4. 1, 2, 3. It's probably going to be about right there for my point. And then the other thing that I know is I didn't get it exactly right, but the other thing that I know is my y-intercept is this. So I do roughly have enough points to get that. Does that make sense to you, gentlemen?
Mhm.
Yes.
Okay, so I've got 3 points, and that's really all I need to graph a parabola. And given the rule of the symmetric piece to parabolas, you can kind of sketch it with these points using the symmetry for a parabola. You can get those. So if you've identified at least 3 points, which you can use the y-intercept, the axis of symmetry, the vertex to get those. Is there another one in particular that you would like for me to work? Is there another fraction one?
I needed help with like 33 till the end.
Okay. Benjamin, did you want me to do another one that had a fraction or, the minimum and maximum?
Mhm.
Is that all we had to do, 33 to the end?
That was part of it.
Tell whether the function has a minimum or a maximum, and then
Well,
give the value.
33 to 41 odd.
Okay, 33 through 41 odd.
Yes.
Okay, cool. All
And
right.
then 44 through 46 would also be helpful as well.
Okay. Okay, great. I can do that. And for those, I'm just going to pull up the book. Okay, let's talk about minimum and maximums for just a minute. The minimum and maximum value is going to be the y coordinate of the vertex. Okay, so you know the value of it is just going to be whatever the value of the y coordinate is. Does that make sense?
Is it, if it's negative, does that mean it's a minimum?
If
Is it if the graph is flipped, it's a minimum?
if it's flipped, it means it's going to be a maximum because it won't go higher than that. So if it's negative, it's a maximum. If it's positive, are you talking about the A value? Because the A value tells you whether it's a minimum or maximum. Okay, does that make sense?
So if it's negative, it's a maximum. If it's positive, it's a minimum.
Yes, because, and let's talk about it. Let's look at it so you can visually know why. because I know it feels weird that you're going to have a maximum with a negative and a minimum with a positive. But the whole reason, I'm sorry?
I understand what you mean, though.
You understand why? Okay, cool. All right, so let's look at the first one, number 33. All right, so we've got y equals negative 6x squared minus 1. So remember our a value, which in this case tells us whether it's going to be a minimum or a maximum, because it's going to tell us the direction of the parabola. And in this case, it's going to be a frowny face because it's negative. So we know for sure that we're going to have a max because of the fact that it's a frowny face, and here's the max. The next thing that you're going to do is take that negative b or opposite of b over 2a. And in this case, we don't have a b, do we? It's missing. So you would just plug in a 0 for that. So we actually have the opposite of b, which in this case is 0, over 2 times negative 6, which really is superfluous because it's still going to be 0 no matter what. So
it's on the origin?
That's for the
Why?
Lord Jesus.
Vertex?
Yeah. That's for the x coordinate of the vertex. But if I plug in 0 back into it, I'm going to get negative 1. So in this particular case, the vertex is actually the y-intercept. Okay?
Mm-hmm.
And so the maximum value is negative 1.
So the answer is not 0, negative 1?
No, it's just 0, negative 1 is the vertex. And the only reason I'm showing you that is the axis of symmetry is the 0, and the maximum value is the axis of symmetry is the x coordinate, and the maximum value is the y coordinate. So they both have a purpose in the vertex. Okay, so the x coordinate gives you that axis of symmetry, and the y coordinate gives you the value of the maximum or the minimum.
Okay.
Okay?
Yeah.
Does that make sense?
Mm-hmm.
Okay, how about for you, Benjamin? Is he still with us?
Yes.
Oh, okay. Okay, all right.
My mic was muted.
Oh, okay. I understand. Most of the time when I'm on here, I get feedback. And it echoes through my house. All right, let's work a few more of these maxes and mins just to make sure we have the concept down.
There's only 2 more of them, so.
Oh, okay. Oh, is it odds?
Mm-hmm.
Thank goodness y'all are telling me because okay, so number 35, is that correct?
Yes.
Okay. All right, so number 35 is f of x equals 2x squared plus 8x plus 7. Okay, so my A is 2, my B is 8, my C is 7. So the opposite of B over 2A in this case is the opposite of 8 over 2 times 2, which is going to be the opposite of 8 over 4, which is negative 4. So now I'm going to take that negative 4 and plug it back into my equation.
Wait, negative 8 over 4 equals negative 4?
Oh, no, it doesn't. Thank you.
2.
Good catch. Good catch.
2, or negative 2.
Yes, you're absolutely correct. Thank you. Appreciate you speaking up.
Do we just put
And
the
then you
negative
plug
2.
that number back into the equation because this is the x coordinate of the vertex, and you have to have the y to get the minimum or maximum. Does that make sense?
Mm-hmm. Is it negative 17?
It's -1 because I've got
That's the big
8 plus -16, which gives me a -8 plus 7. So that's -1. So, and the A value is positive. So you're going to have a minimum value of -1.
So wait, what's the vertex like points? -2, -1?
Yes, sir.
And then the minimum value is -1.
Yes. And the
Okay.
only reason I need to even find the vertex part, the only reason I need to do that is because I have to get that x coordinate to be able to plug it back in, because the y coordinate is what drives the actual value of whether it's a minimum or maximum. This A thing right here, whether it's positive or negative, tells me whether it's going to be a minimum or a maximum. Because it's positive, it's going to be a minimum because I've got a cup shape.
Mm-hmm.
So the vertex, which would be -2, -1 in this case, is going to be at the bottom. So that's the minimum value. All right. So then number 37. I wish there was a way to just clear this screen without having to erase little by little by little.
You could make the eraser bigger.
I really, I don't know how to do that on Cami. Do you know how to do that?
No.
Yeah, unfortunately. Oh, look, I just hit highlighter. Trying to make the eraser bigger. My bad. Just discovered the highlighter, though. I didn't know I had that. Yay. All right, what am I, number 37?
Mm-hmm.
Oh, yay, it's a fraction. Everybody's favorite.
Yay.
3/2 x squared plus 6x plus 4. So my A value is 3/2. My B value is 6, and my C is 4. So -b over 2a equals the opposite of 6 over 2 times 3/2, which this one's an easy fraction because this actually cancels. 2 goes in, simplify before you multiply. So that turns into 3. So that's going to be -2. Trying to do my reducing right this time. And then, so I'm going to stick in, oh, this is a pleasant one. Stick in -2.
Is that 3? Is it 3 squared? Can you stick it in there?
I'm sorry?
You put -2 into the equation, that first one, when it's being multiplied by 3 over 2, is that 3 squared? And you're solving for the second part of the.
I'm solving for the y part of the vertex because I got the x part. Oops. I got the x part, right?
Mm-hmm.
So when I'm sticking it back in, I have to solve for the y because that's going to tell me whether it's that's going to tell me the value of my minimum or maximum. Right?
Mhm.
So it's actually -2. And since this is positive, I know that my parabola is going to be going up. So I've got a minimum value of -2. Does that make sense?
Yeah.
Okay. And then number 39. Did y'all have to do that one?
Let me see.
Yeah.
Okay. So number 39.
We go to
I think I have-
41.
Okay. Can't everybody understand number 39?
I like to do it.
What is the effect on the graph of the function y equals x squared plus 2 when it's changed to y equals x squared minus 3? The change is that it's moving along the y-axis, and it's the parabola still carries the same shape. It just the vertex is moved from 0, 2 down to 0, -3. So it's shifted down 5. Does that make sense?
So it's
Yes.
B.
Do you want to see that, Garrett? That's just back to our good old parent function.
Isn't it?
I'm sorry?
I can hear myself talking on your end.
Oh, I hate it. So you're getting feedback?
Mhm.
Oh, I hate that. I'm trying to pull up the book. But I can do something to show that for you. What page is this? 7? So matching these graphs, to the right one, I can.
Wait, what problem are you doing?
Well, I could go back to 39, but I was going to start with. Oh, you want me to do 41 also, don't you?
Yeah.
Okay. All right. Easy enough. But do you want to see 39 done?
Is it D?
Yes.
Okay, I'm good then.
Okay. All right. So number 41. The path of a basketball thrown at an angle of 45 degrees can be modeled by y equals -0.02x squared plus x plus 6. And the instructions are to identify the values of a, b, and c for the quadratic function. So given that the quadratic function that's what I've been doing on all of these, is writing down the values of a, b, because the quadratic function is ax squared plus bx plus c. So if that's the case, the coefficient of the x squared variable is the a. The coefficient of the bx, or the x, the one with the x variable, is the b, and the constant that's all by itself is the c.
Okay, I can understand that.
Okay, great. So what would the a be?
-0.02x squared.
Yes, yeah, but you just have to say the coefficient of it, which would be negative 0.02. You don't actually have to add the x squared when you're giving the value of a, b, and c. So what would the value of b be?
X.
Just one.
One.
You're
Okay.
just looking for the coefficient. Okay. And then the value of c?
6.
Right. So yeah, you just when you're identifying those values, you only have to give the number or the coefficient that precedes the variable. Does that make sense?
Yeah.
So just to make sure that it's clear, let's do number 42. What is the a value for number 42?
Negative 0.01.
Perfect. And what is the b value?
0.7.
Perfect. And then once again, that has the same c value as number 41, which is 6. Okay. Did y'all have to do 43?
We skipped to 44, and we do 44,
Okay.
45, and 46.
44 through 46. Okay. So looking at these, it's better to just kind of look overall and let's think about everything that we've learned so far about graphs. Okay. And like parent functions and all of that. First of all, there's one of them, there's two of them that go through the y-axis at the point of 3. And that's going to be number 45 and 46. Okay. So we're looking, does that make sense to you?
Yeah.
Okay. So then what we can say is the one that doesn't go through and show 3 as a y-intercept is going to be number 44. So which one would that one be?
C.
All right. So 44 goes with C. Good job. All right. Now, the next thing that we can do is figure out the fact that number 45 is almost exactly like a parent graph with only one shift along the y-axis, and also it gets a little fatter because of the 0.5, because it's less than 1. So that means that it's only going to shift up the y-axis by 3. So which one would that one be?
B.
Try one more time.
Well, A then.
The vertex is going to be on the y-axis at 0, 3, because it's only shifting up 3. Does that make sense? Not really?
I'm having a bit of a...
Okay, so look at number 45 and realize that if I didn't have the 0.5 in front of that, it would just be x squared plus 3. And what you would have told me for our unit 1 on parent functions is that would have been just shifted up 3. It wouldn't have gone left or right at all. So it would have stayed on the origin as far as the x was concerned, but it would have just been shifted up 3. Does that make sense?
I still don't fully get it.
Okay. Let me. Every time I split the screen in MathLab, it doesn't split well. So I'm going to try to write it here. And then, so y equals 0.5x squared plus 3. Our parent function was y equals x squared. Remember that? Ugly parent function? Mm-hmm. And if I would have said to you, okay, on this parent function, the vertex went through the origin, didn't it?
Yeah.
And it looked just like that, right?
Mm-hmm.
Okay. So if I shifted it up 3, it would have just moved like this, correct?
Yeah.
It just would have gone up to here. And then when I add 0.5 in front of it,
No. So is it A?
it just gets a little fatter.
It's 45A.
I have to go back to the book now. Well, wait, let me see. Yes, it is.
Okay, I
So
understand.
44 was C. 45 is A. And so then number 46 is B. And you could kind of see that because we know the vertex is going to be shifted definitely because of it being in standard form there. And we know the y-intercept is going to be 0, 3. So are you kind of seeing how the parent graph gets shifted and moved and how that moves the equation around?
Mm-hmm.
Does that help?
Yeah.
Okay.
That's all I need to know, though.
Okay.
Thanks so much for helping me.
Oh, no problem. I don't mind at all. And Brooke, looks like Brooke Williams joined us for a little bit and then she left. I hope she got her question answered. And then Gabriella was here for a minute too. I know a few people have questions, about those fractions, but we had already covered those. I feel kind of bad. But I'll try to get those in class, and I'll definitely let Miss Wynn know that Brooke showed up. Is Brooke in your class?
I don't know.
Okay. All right. I'll let her know that she was here so that she might have a question on the fraction one. That seemed to be the one that was hardest.
I did have a bit of a hard time with those.
Yeah.
Well, I'm going to go finish the rest of them.
Okay. Talk to you later. Bye-bye.